In this video, I'm going to talk about the worksheet C, Polyatomic Ionic worksheet, ionic compound worksheet rating formula. That means if I give you the compound name, you will give me the formula. So before I introduce, I want to talk about the polyatom list. Now this poly meaning like multiple atom. So I have two ways to organize the polyions. One is by the charge. So I categorize them into +1 charge, -1, -2, and -3. And -1, 2, 3 are the anions, so there are many of the anions, they are poly. And the ammonium, not aluminum, ammonium and hydromium are the only two that are cation poly. Okay, so that's the one way is to organize by charge. And the other way is organized by alphabetical. So if I give you the compound name, you don't know how it look like, you don't know the charge, anything, you can just look up the alphabetical and then you can find the formula. You'll notice that all of them have parentheses with the charge outside, and you cannot touch anything inside the parentheses. For example, you cannot take away the 4 from an H. Okay, you cannot touch anything inside parentheses. They're unique. Now, the C step is similar to the A step. Okay, so that means you're giving compound name, you will be writing formula. So if you compare the poly thing here, the poly anions, many of them are ending with ATE, and many of them with oxygen. So for example, nitrate, phosphate, sulfate, they have oxygen, and they end up with ATE. If you compare this poly to the one mono, now mono is ending up IDE, and they don't have oxygen. For example, nitrate, phosphide, sulfide, they end up with IDE, and they have no oxygen. So some people will probably confuse about, I don't remember nitrite or nitrate, sulfide or sulfate. Well, how do I remember the poly has ATE and is oxygen? Is I write the sentence here. I say, I ate an orange. ATE with oxygen. Okay, oxygen is ATE. Okay. Now, first of all, we're going to name the cation first and anion next as usual. Okay, so I give you the example, chromium 3 phosphate, and I want the formula is CrPO4. So how do I start it? So first, you write down the cation, anion with the charges. So chromium 3 is Cl3 plus. Phosphate is parentheses Pl43 minus. Now, how do I know that this formula is because NATE? ATE is a poly with the oxygen. It means that I cannot find the phosphate from the periodic table because it's not phosphide, it's phosphate. Okay, it's ATE with the oxygen, it's a poly. That means we have to find the phosphate from the poly sheet. So phosphate, I have parentheses PO43 minus. So I copy on here. That's step 1. Step 2, you call circle the coefficient only on the top and cross over to the bottom as subscript. And do not touch the charges, just like the A1. You circle the subscript, the charge only and cross over to the bottom. And step 3, you write the formula. Now here, you cannot touch anything in the parentheses, okay? You cannot touch PO4. So we can only look up this 3 and this 3, and we can simplify. So we divide by 3 to this 3. We cannot touch PO4. We cannot touch anything, okay? So I got CR1, parentheses, PO4, close 1. And remember the formula, we don't want the 1, so we have to take away the 1. So we take away from the 1 from the CR, no problem. Now, what is the purpose of parentheses? The purpose of parentheses is to separate the number from inside and outside the parentheses. Again, the purpose of using parentheses is to separate the number from inside and outside of the parentheses. If you take away the 1 here, I have no more number outside parentheses. So there's no need to keep the parentheses. That means when I take away the 1, I also need to take away the parentheses. So when I take away the 1, I will take away the parentheses. So I will only have CrPO4. So the answer cannot be Cr parentheses PO4 close. Cannot, because I have no number outside. There's no need to keep parentheses. So Cr parentheses PO4 is wrong. Should be no parentheses, CrPO4. So again, when are you going to take away the parentheses? Is when you take away the 1. Otherwise, you have to keep the parentheses. Okay? So let's look up the example here. Be2 plus OH minus. Now, we can find the hydroxide from the list. Is hydroxide. Let's see. Hydroxide is right here. Hydroxide, OH minus. Okay, we found it. So we write down OH minus. And then when we start to cross over, we put the 1 back. Okay, we circle the 2, we circle the 1, we'll bring that down, become BE1OH2, parentheses 2. Now I have to keep the parentheses because I cannot take away the 2. I can only take away the 1. So if I keep the 2, I did not take away the 1. I cannot take away the parentheses. So the answer will be only BE parentheses OH close 2. I can only take away the 1 from BE, but I cannot take away the parentheses because I did not take away the 1. In other words, the answer is not BeOH2. It's not BeOH2 because if you take away the parentheses here, you're telling me that I only have 1 oxygen and 2 hydrogen. And indeed, I should have 2 oxygen and 2 hydrogen. Now, what's the consequence? If you did not have the right formula, when you go to Unit 7, your formula would be, oh, I only have 1 oxygen instead of 2. So when I calculate the formula, molecular formula, I have the number wrong because I should have 2 oxygen instead of 1. So here again, when are you going to take away the parentheses? Is when you take away the 1. And since I have the 2 here, I cannot take away the parentheses. Okay? So let's just do one question. Ammonium nitrate. Now this ammonium, not aluminum. Ammonium is one of the 2 cation, they are poly. So ammonium, NH4 parentheses plus. I'm going to use blue pen. So parentheses NH4 plus. Okay, and nitrate is ATE. So I can find it from here. Nitrate is parentheses NO3 close minus. Okay, and then I'm going to rewrite on here, NH4, but I had to give the 1 on the plus. And parentheses, NO3, and I have to give the 1 to the minus. Okay, now we circle the number. We brought them down. Okay, I forgot to add the arrow. Make sure you add the arrow to all the equal sign. Add all the arrow to the equal sign, okay, because we're going to flip the arrow. Add all the arrows to the equal sign. So after that, I will get parentheses NH4 close 1, parentheses NO3 close 1. Okay, now remember you need to take away the 1. And again, my slogan is take away the 1, take away the parentheses. So you take away the 1 and you take away the parentheses. Then the final answer would be no parentheses, just NH4 NO3. Okay, now see the example here, calcium carbonate. Okay, so here Ca2 parentheses CO3 close 2. Again, I cannot touch the CO3. I cannot touch anything in the parentheses. But the 2 and the 2 here, we can simplify. We divide by 2 to get Ca1 parentheses CO3 close 1. Now here, I take away the 1. I take away the parentheses. And I also take away the 1 from Ca. So my answer is CaCO3 without the parentheses. I take away the 1. I take away the parentheses. Okay, so here, magnesium phosphate, okay, here I have to keep the parentheses because I did not take away the 1. I have the 2 outside. I have to keep the parentheses. If I take away the parentheses here, I will become PO42, which is really weird. And again, I cannot change anything in the parentheses. So I have to keep the parentheses here, okay? So let's do let's look up the nickel Vi phosphate. So Ni6 plus PO3 close 3 minus. And again, I cannot touch this PO3. I can't touch it. I can only develop the 6 and 3 here. So I get Ni1 parentheses PO3 2. Now here I have to keep parentheses because I did not take away the 1. I keep the 2. So I have to keep this to become PO3 close 2. Otherwise, it will become PO32, which is wrong. So let me do the tin IV carbonate. Tin is SN4+. Carbonate is the poly. Carbonate is right here. Parentheses CO3 close 2 minus. CO3 close 2 minus. Okay, so I'm going to rewrite it as SN4+. Parentheses CO3 close 2 minus. I circle the 4. I circle the 2. I brought the 2 down. I brought the 4 down. Okay, so I got SN2 parentheses CO3 close 4. Okay, again I cannot touch CO3, but I can simplify the 2 and 4. I divide by 2 to get SN1 parentheses CO3 close 2. Okay, in this case, I have to keep the parentheses because it will become CO32. But I can take away the 1 from the SN. So the answer is the SN parentheses CO3 close 2.